Welcome to the distance learning program on Android by Inabus. In this chapter, we will be covering Android Location and Android Location Manager. The topics covered under this chapter are using Location Manager and Location Provider API, simulating our current location within the emulator, and converting places and addresses with Android Geocoder API. Using Location Manager and Location Provider API. Under this heading, we will be covering accessing location data using Location Manager, using a location provider, and receiving location updates with the Location Listener interface. Accessing location data using Location Manager. The various steps involving in accessing location data using Location Manager are: the Location Manager API provides access to the system's location services. The Location Manager class helps in the following tasks: obtaining a user's current location, tracking the user's movement, setting proximity alerts, and detecting available location providers. Using a location provider. The various steps involved in using a location provider. A location provider provides periodic reports on the geographical location of the device. Each provider represents a different location finding technology used to determine the device's current location. Location providers differ in various capabilities like power consumption, monitoring cost, accuracy, altitude determination, speed, and heading information. Receiving location updates with the Location Listener interface. The various steps involved in receiving location updates with Location Listener are: creating an instance of the Location Manager class, creating a criteria object and setting the various criteria settings on the object, fetching the best provider for the mentioned criteria, registering for location updates using the best provider obtained, and implementing the Location Listener interface. We also need to make sure that we override the onLocationChange method in the interface to get the location details. Now let's see a demo of using the Location Manager and Location Provider API. First, we'll create a new Android project and we'll name the project as Location Demo. You'll select a target and name the package. We'll open the project and open the default activity which was created. Now we will edit the main.xml file. We will move the text view to the center of the screen. And we will provide an ID to the text view. We will name it as location text and save the XML file. Now moving to our Android manifest.xml file, we will add the permission to access the location. The access_find location permission can be used when we use GPS or network providers, but we will be able to use only network providers when we use the access_ghost location permission. The difference between the two access permissions is that access_find location will give you accurate details but at the cost of battery, while Access code's location will not drain your battery, but will give an approximate location. Going back to the location demo activity, we will create a text view object and map the text view with the text view we mentioned in the XML file. Having done that, now we will create a location manager object. We will instantiate the location manager object from the location manager service. We will create a new criteria object and set the criteria settings. We will mention the accuracy of the criteria as accuracy fine, which makes sure that we use the GPS provider to access the location detail. Now we will fetch the best provider for the following criteria. This is done by calling the getBestProvider method on the location manager object. We need to pass the criteria as the parameter of this method. The second parameter accepts a Boolean value which indicates whether the providers are enabled or not enabled. To receive the location updates, we must call the requestLocationUpdates method on the location manager object. This method has 4 parameters: the provider, the minimum time, the minimum distance, and the location listener. The best provider which we obtained in the previous step can be provided as the parameter for this method. The minimum time is represented in milliseconds. The minimum distance is represented in minutes. We will implement the location listener interface. The various methods in the location listener interface are on status change, on provider enabled, on provider disabled, and the important one, on location change. This is where we track the location updates. The latitude values and the longitude values can be obtained from the location object. Now we will set these values to the text view which we initially created. Now we can run the application to check whether we receive the location updates correctly. But before doing that, we need to know how to simulate our location in the emulator using the DDMS tool. Simulating the location within the emulator. The location can be simulated within the emulator by the following methods: sending in the coordinates with the DDMS tool, the GPS exchange format, and the Google Earth keyhole markup language format. Sending in your coordinates with the DDMS tool. Open the DDMS tool. Select the desired emulator from the device list. Select Emulator Control tab. Go to Location Control and select Manual tab. Key in the desired latitude and longitude and press Send. The location will be updated with the keyed latitude and longitude. Now we will run our application and update the simulator location details from the DDMS tool. We'll open the DDMS tool from the Android SDK and click on the emulator. Select the Emulator Control tab. Go to Location Controls and in the Manual tab, key in the latitude and longitude values and press Send. Now we will go to the emulator and check whether the location has been updated. The location has been updated and the latitude and longitude values are fetched. The GPS exchange format. It is a simple XML file. It is used for supplying a range of locations. It allows to store waypoints, tracks, and routes. The GPS exchange format is supported by many handheld GPS devices. The various steps in simulating the location using the GPS exchange format is as follows. Open the DDMS tool. Select the desired emulator from the device list. Select Emulator Control tab. Go to Location Control and select GPX tab. Load the required GPX file from the file system and press play button. This is an example GPX file. The route tags are the GPX and it contains waypoints, tracks and routes. The WPT tags mention the waypoints. The TRK tags mention the tracks. Every waypoint has its name and description. Every track contains track segment, which in turn contains track points, which are nothing but waypoints. Now let's see how to load this GPX file and simulate our location. Go to the DDMS tool, select the emulator, click on Emulator Control, go to Location Controls, select GPX tab, load the GPX file, and the waypoints and the tracks are shown in the grids. Select one of the tracks and press the play button. The speed of the tracks can also be changed. After pressing the play button, go to the emulator to check the location change. The latitude and longitude values are changing based on the waypoints in the track. The Google Earth Keyhole Mockup language. It is also an XML file similar to GPX files. The steps involved in simulating the location using the KML file is similar to that of GPX files. Open the GDMS tool. Select the desired emulator from the device list. Select Emulator Control tab. Go to Location Control and select KML tab. Load the required KML file from the file directory and press Play button. This is an example of a KML file. It is an XML file and the root tags are the KML tags. The placemark tags are in between the KML tags. Every placemark tag contains name, description and point tags. The point tags contain the coordinates, that is the latitude, longitude and altitude of the locations. Now let's load this KML file to the simulator and check whether the location is simulated. Open the DDMS tool from the Android SDK, select the emulator, click Emulator Control, go to Location Controls, select KML tab, press Load KML and load the KML file. The various place marks are shown in the grid. Select one of the place marks and press Play button. Go to the emulator and check whether the location has been updated. Converting places and addresses with the Geocoder API. Geocoder. The Geocoder class helps to translate between street addresses and latitude-longitude map coordinates. The geocoding is done on the server, so it is necessary to mention the Android Internet Access Permission in the Android manifest file. This class provides two geocoding functions: forward geocoding and reverse geocoding. In case of forward geocoding, the latitude and longitude of an address is found. In case of reverse geocoding, the street address for a given latitude and longitude can be found. Now we will see a demo of using the forward geocoder. First, we'll create a new Android project and name it as forward geocoder demo. We'll select the build target and we'll name the package. And press finish. Now we'll open the default activity which was created and we will edit the layout file of the activity. We will remove the text view which was already present inside the view. We will add a multi-line edit text box and edit its properties, and we will set the number of lines to be 4. We will also set a hint to enter the address here. And then we will place a button below the edit text and edit its properties. We'll set the text as fetch location. We will also add a text view so that we can show the result in the text view. We'll set the text of the text view as location and save the XML file. Now going back to the activity, we will create a edit text object and map it to the edit text we created in the XML file. Similarly, we will create a button object and map it to the button we created in the XML file. We will write a button on click listener inside the on click function. We will write the necessary code to convert the address into location. First, we will create a geocoder object. Then we'll get the address from the text box and assign it to a string. We'll create a list of object type address to store the addresses. Now we will create a try catch block. Inside the try block, we will assign the list with the values obtained by using the get from location method on the geocoder object. The location name will be the address. This method also accepts a second parameter, which is the maximum number of results to be returned. We will set it as 10. And then in the finally block, we will create a text view object and assign it to the text view we created in the XML file. We will get the latitude value from the first location in the list. Similarly, we'll get the longitude value also from the first location in the list. Now we will assign this latitude and longitude to the text view text. Before running the application, let's add a permission to the Android manifest file. Since the geocoding takes place at the server end, it is necessary to add the internet permission. Now let's run our application. The forward geocoder demo activity is launched. I click on the edit text box and search for New York, USA. And I press the fetch location button. The text is populated with the latitude and longitude value of New York, USA. Now we will see a demo of reverse geocoding. First, we will create a new Android project. I'm named the project as reverse geocoding demo. We will select the build target and name the package. And press finish. Now we'll open the default activity. We will edit the layout file of the activity. We will remove the text view which was already present inside the view. We will enter two text fields. And a button. We will also add a text view to show the result. Now we will edit these widgets. We will set the hint of the first edit text as enter latitude and hint of second edit text as enter longitude. the text of button as fetch address, and the last text view as address. Now we will save the XML file and go back to the default activity. We will create two edit text objects and map it to the two edit texts we created in the XML file. We will create a button object and map it to the button in the XML file. We will write a set onClick listener function for the button object. And inside the onClick function, we will write the necessary code to convert the lat and long into a valid address. First, we will create a geocoder object. We will create a list of addresses to save the result. We will create a try catch block, and inside the try block we will use the geocoder to get the location details. The latitude value can be obtained from the edit text box. It's also necessary that we convert the string from the edit text box to a double value before we pass it to the parameter. Similarly, we also do that for the longitude value. And we'll set the max results as 10. Now we'll create a finally block. We will create a text view object and assign it to the text view we created in the XML file. We will set the text view text with the address of the first location we obtained from the result. You'll get the locality and concatenate it with the country name. Now, before running the application, we will add the internet permission to the Android manifest file. Save the manifest file and then run our application. The reverse geocoding demo activity is launched. I enter the latitude as 40.117 and the longitude as -74.012, and I press the fetch address button, which loads the result as New York, United States of America.